Okay, so we're going to use a reduction formula here. Write an equivalent expression for cosine to the fourth x that does not involve any powers. Now, they say any powers. They mean any power greater than 1. Oh, I guess they say that. Any powers of sine or cosine greater than 1. Okay. So you might say, well, I'm starting out with a fourth power. So what we want to do is we want to think of it as cosine squared x squared. Okay? Now, we know something about cosine squared x. We can use the reduction formula. So the reduction formula said cosine squared theta was equal to 1 plus cosine 2 theta over 2. Make sure I get the right one. Yeah. Okay. So I'm going to rewrite this then as 1 plus cosine 2x over 2, and then that whole thing is being squared. Okay? All right, so I'll let you look at that for a minute. What's happening here? X is like the theta, so we're making it 2 theta, right? Because that's what we have to do from the formula. So it's 2x. And so we've reduced it. You know, we got rid of, now it's not to a fourth power, at least. Okay, so what we're going to have to do is we're going to have to square the numerator. We're going to have to square that. And we'll have to square the denominator, which is going to be 4, but we'll just write that in a minute. Okay, so in the numerator, when I square that, I'm going to get 1 plus 2 cosine 2x. You could FOIL it out. I guess I need another parenthesis there. You could FOIL that out. It's in a binomial form, like this is A and this is B. So, you square this, multiply it, double it. That's why it's 2 cosine 2x. And then we're going to have to square this, so I'm going to write that in, plus cosine squared 2x, all over 4. Okay. Now, we're getting there. We still have an exponent, though, right here. And we're not supposed to have any exponents on sine or cosine. We don't have any sine functions in here, just cosine, so we're okay there. We're going to take this 4 in the denominator and write it out here. So 1/4 times 1 plus 2 cosine 2x, very common to do this, plus, okay, now this, we're going to use that double angle formula again. So it's going to be, I'll write it in green here. Okay, well, it scrolled off, but it's going to be 1 plus cosine, and I'm going to write this as 2 times 2x, because this 2's from the formula, and this is my theta right there. That's like my theta, okay? All over 2. Okay. And then I need another parenthesis, big one out there. Okay. So it looks kind of goofy the way I have it written, but that's what it is. Okay, so now let's see what we can do to kind of clean things up. So I'm going to go ahead and leave the 1/4 out here for a minute. 1 plus 2 cosine 2x plus, and we can make this, 1/2 times 1 plus cosine 4x, like that. I guess I need another parenthesis. Okay, and now I'm going to go ahead and distribute. I mean, there's, I could distribute this first. Let's distribute this first. Okay, so we'll, I kind of didn't draw my arrow good, but it's going to that term. So leave the 1/4. There we go. Well, I wrote 1/2, didn't I? Okay, leave the 1/4. I'm going to bring in a bracket. So 1 plus 2 cosine 2x plus, and then I'm going to have 1/2 plus 1/2 cosine 4x. So it's looking a little better. A little better. We want to combine the 1 and the 1/2. So it'll be 1/4 times, it's going to be 1 and 1/2, that's going to be 3/2, plus 2 cosine 2x plus 1/2 cosine 4x. And then finally what I'm going to do is I'm going to distribute this 1/4. Okay, so there's three terms. There's this one, and this one. And so it's those real number coefficients that we're multiplying by. And so what do we get? We get 3/8 plus, now it's 1/4 times 2, which is going to be 2/4 or 1/2 cosine 2x. It doesn't change the argument of our function at all. We're just taking 1/4 times the 2, this 2, the 2 in front, okay? Plus 1/8 cosine 4x. And then that's going to be our answer. We don't have any exponents on the cosine function, so we're good.